Welcome everybody to the August 2024 Raleigh Astronomy Club meeting. Any new club members in the room today? Welcome. Anybody on Zoom? I can't see hands, but if you are new, welcome. Um, so we are, so despite what we say on the slide here about holding questions, we've been told that for this particular session, ask questions as you go, please. Raise your hand in the room. I'll bring this microphone to you. And if you're on Zoom, you have an option. You can either type it into chat, which we'll monitor, or we can ask you to unmute to ask your question. Safety. Oops, hit the wrong button. There we go. Identify room hazards. So there's some wires in the back. What, Steve, are you a hazard? Be aware of stuff on the ground, tripping hazards. Oh, okay, there's a list. Cables behind the projector, chairs, bags. We don't have a lot of light in here. It's not too bad, but just be aware. Anybody who's CPR certified, we do have somebody, Frank, thank you. Hopefully we'll never have to call on you. Emergency caller, in case there's a problem or something. Dana, thank you, sir. Fire equipment, we've got a fire extinguisher by the door back there. And I think that's it. Anybody who's remote, please. Similar things, be aware of your surroundings. We have two exits if we need to leave. There's a exit over there on your right and on the left if you go out, and I think turn left, there's an exit out of the building as well. Hannah? Hannah what? Hannah Almond, welcome. Welcome to RAC. Okay, upcoming events. This is going out a couple months because I wanted to get to the last one down there. Just kind of put a plug in for it. So we've got Art Space happening tomorrow. We got an imaging meeting next week on Thursday, the 22nd. Beyond the Flames, Astronomy Amidst Wildfires on the 25th. And then in September, we have our first Friday overlapping with RAC on the 6th, followed by a class on the 7th. This will be an astrophotography based class on equatorial mounts and like fully automated rigs. We have our imaging meeting on the 19th of September. Our next indoor meeting, September 27th in this room here and on Zoom. Betelgeuse will at supernova soon. Should be interesting. The week starting September 30th is the Stanton River Star Party. Registration is open. I registered sometime this week. It's kind of a blurry week. I don't know what's happened. October 4th, again, first Friday, and RACOB's overlapping. And then we have to set a date for it. But in October, we're going to do a barbecue similar to what we did last year. So look out for announcements of the date when we have that one. Oops. I don't even know what button I just pushed. Yeah, it would be on a Saturday or Sunday. Yeah, it would not be on a Friday. Hey, Dana, could you hit the present button? I don't know what I did. I didn't know that was possible. Apparently my clicker is more fancy than I thought. Just hit present or slideshow top right. Yes, please. Thank you. Okay. Afterwards, we're going to go to Hibernian. Address is here, and we'll show this slide at the end as well if people are interested. Quick show of hands, anybody who might be going. All right, quite a few people. Awesome. All right, today, I'll pull my bio up. Today we have Mr. Ken Brandt, is a veteran planetarium director and science educator. He runs the Robeson Planetarium, a small school-based planetarium and science center in Lumberton, North Carolina. He has a master's degree in science education from the University of Florida and has been a NASA solar system ambassador for 22 years. He is the most recent recipient of a fellowship in the International Planetarium Society, an organization he also serves as the co-chair of their education committee. So tonight, Ken is going to talk to us about Curiosity and its 12 years roving Mars. And now we're going to have to switch presentations, so give us a moment.
Test one, two, test. Are you hearing me okay on the audio? Oh, excellent. Okay, good evening, everybody. All right. Hopefully, ooh, what a beautiful picture. It's a bright sunny day. We don't have too many of those. Oddly enough, I woke up not last night, but the night before at 3 a.m. and it was crystal clear, like for the first time in how long? Right? A long time, crystal clear. And I saw five, count them, five Perseids and a couple of strays. What are those called? The ones that aren't part of the meteor shower? I don't know. Outliers? I don't know. Anyway. Oh, wow. Oh, right. Okay. Okay. I can do that.
With hovering to get into.
Sorry. How do I get into my sharing?
Go back to Zoom.
Whoops. All right.
Tab over to Zoom.
Okay, I'm gonna have to exit out of that for a minute. Okay. All right.
More. Share in the top. Share, and then we're going to check.
Make sure.
Option for audio. You have that checked, and pick your screen.
That should be it. Okay. Okay. I'm going to move this window out of the way, hopefully, so it's out of sight and out of mind. Okay, now try and get my slideshow to go. Give me a second there. It's my computer is slow. What do you want for $200? Okay.
Close that.
Sure.
So it shows up as like a.
Right. There we go. All right. Okay. All right. I'm going to give you a chance, about 15 seconds, while I'm talking about how I like to teach, because that's in fact what we're doing here, isn't it? I might as well be fourth graders, and I could do worse than treat you like I treat my fourth graders. Let's put it that way. If I'm treating you like fourth graders, you're in good hands. Nothing bad's going to happen here. I've got all kinds of goodies for you to take home with you. Okay, there's perseverance posters suitable for hanging in classrooms. If you know anybody who is a science teacher or who wants to motivate their kids to persevere, perseverance is not just a rover on Mars, it's also a character trait. If you know anybody who is high school age or college age and they want to find out about NASA internships, this is not a bad place to start right here. A little bit about the planetarium, which I've redundantized up here. I'll be giving out door prizes during the presentation, especially if you are going to be leading an outreach event. It's going to have several people. I have packs of 100 of these cool lithographs for you to give out to your audiences. Okay. And if I don't give all these out, say again? All right. Well, see me after the presentation. I don't want to bring any of this back with me. Okay. This is all, I do not, I got to bring it back to the car, and the car's about a quarter mile away at the electric charging station. I've also got some postcards featuring different planets, which we will do. And I've got some very special door prizes here. Special door prizes. These are 3D of Europa from the Europa Clipper mission. Ooh, you can't just go out to the Walmart and get these. This is a special issue, as they say, only to those of us who wear the badge. And if you don't wear the badge, maybe you ought to think about applying. Next month is when the Solar System Ambassador Program opens its doors for applicants. It's open all through, I believe it opens September 15th, but I can't swear to that. I know it's in September. Okay.
Do you have your NASA stickers with you?
I do not have any NASA stickers.
Okay, you just got a -1 for your SSA this month.
I have everything. Okay, you know what? I'm sorry. No. I'm not going down without a fight. I got all kinds of good stuff up here, and I figured NASA stickers are, you've seen them, right? It's got a meatball on it with NASA on it. Maybe you've heard of it. Yeah, one of those. There you go. All right. But since you asked the cool question about the NASA stickers, you get an insight pin. There you go. I've only got 12 of those, and there's more than 12 of you here, so I can't give everybody one. Oh, the Robeson Planetarium, thank you, is in Lumberton, North Carolina, in Robeson County. We've been there, believe it or not, for 55 years. The last 8 years, we've been running the inflatable version because the real version is under about 4 feet of water. Thank you, Hurricane Matthew. Ow. Oh, I'm on like a video, aren't I? I shouldn't have done that. Sorry. Okay. Over there, safe. Cool. Now I know where. Go off here, over here for off camera. Awesome. I'll remember that. Thank you so much. The main planetarium has gone permanently. That's the bad news. The good news is you're going to be having a RAC meeting in Lumberton in about a year and a half when I open up the new dome. And, you know, if you think the Moorhead is good, hold my beer. That's all I'm going to say. Okay. We got an 8K video system over 40 feet. They have a 4K system over 70 feet. You do the math. And talk about pixel spread and all that other happy nonsense. As I told Todd Boyette, the director, you know, y'all come down when you want to see your videos rendered properly. Come on down. We're happy to have you anytime. Thank you. Thank you. It's a long way to the top if you want to rock and roll. I have to tell you, it's been a struggle. And I'm writing the book, by the way. And the book is going to be all about the trials and tribulations of getting another planetarium built in a dirt poor community that doesn't have like $20 million to build a new planetarium. Fortunately, we got a lot of help from all kinds of people who wanted to help. What is that blue line? This? Oh, okay. That's a Zoom artifact. All right. On to the meat of the presentation. You've had enough time for the QR codes. If you're not doing it, you ain't going to do it. Sorry. All right.
Yeah, it's an annotation. And can I get you to turn your video off?
My video off.
I don't know how to erase.
I don't even know how to do that.
Yeah. It's in the. Yeah, how is that laid over?
How did that even get in there?
Well,
right click on it? What, on the line?
No, go to Zoom maybe.
Okay. All right, we're not gonna. You know what? It's what we call it. It's a 1202 program alarm. We're gonna go ahead and go with that alarm, as Neil Armstrong would say. Screw this. We're doing it anyway. All right. All right. What are we doing with Zoom now?
So let's see.
I got to get rid of my video. There we go.
Video off. Good. And then annotate. Click that. Maybe that'll turn it off. Okay.
Oh.
Nope. You gotta. That's not what we want. X. Close.
Yeah. I'm just gonna leave it there. I don't care.
Okay.
That's not that big a deal. If you guys can handle it, I can handle it. All right. I don't care. That blue line's supposed to be there. That was the path of the helicopter when it was flying. No, anyway, kidding. Okay, so yeah, there's all my goodies. There's my email address if you want to contact me about anything. You know, my inflatable is not a bad place to take the family. We got a cool little science center about twice the size of this room with a big 6-meter dome in the middle of it. And we do some pretty good work down there. So if you're bored, you want to drive an hour and a half, you know, come on down. We'd be more than happy to have you. Our next show is actually September 14th. If you clicked on the QR code, then you've already gotten that information because it's on my website. And that's where that QR code takes you. Let's get to it. Sorry. Okay, so when I say go down, what I want you to do, okay. So somebody tell me real quick the name of the instrument aboard Curiosity that plays Happy Birthday to itself. Anybody know? Or you can tell me what it does, and you'll get the cool 3D thingy and a pin. There's a Happy Birthday song, which you're about to hear. It's courtesy of the SAM, Spectroscopic Analysis on Mars instrument. So here we go. Hopefully this will play, and hopefully we get audio here. Okay.
My name is Florence Tan. I'm the SAM Electrical Lead Engineer. I work at Goddard Space Flight Center. SAM stands for Sample Analysis at Mars. It is an organic chemistry lab on the Curiosity rover. It is the most well-equipped chemistry lab that we've sent to Mars to date. Curiosity landed on Mars on August the 5th, 2012. It was born on Mars that day, and so we consider that day as its birthday. We're here at the testbed lab where SAM is built. It is an identical unit to the unit on Mars, and we use this unit to test our experiments before it is transmitted to Mars. SAM will be running some great science experiments on Mars. We will be analyzing some soil samples. To make the soil samples go down, we had to program it to vibrate at various frequencies. When we're introducing a sample into SAM, it'll go through a resonance and it'll sound like this. To commemorate SAM's birthday and Curiosity's birthday on Mars, we decided to play a little song. If there's anyone listening on Mars, on this special occasion, you will hear this.
No, but if you were listening to it on Mars, it just shakes the tube and it can make those different notes based on how fast it makes the tube shake, basically.
I was thinking with the atmosphere being so thick.
You could hear, I think so, because there are microphones on Mars that are recording wind. So I don't know for sure, but yeah, I'm sure it's not as loud and clear as we get. All right, so these are the Mars. Okay, these are the Mars rovers and landers since 2000 or 1971 rather. The Mars 3 landed on Mars and sent back about a third of an image before it broke down. So you kind of have to, I don't know if you count that as a successful mission or not. The Soviets sure did, but yeah. I don't know. No idea. They weren't very forthcoming back then in terms of, when they fail, they just quietly ignore it. Hopefully you ignore it too, Sojourner, of course, but you get an idea of scale, and this is an astronaut for scale, okay? So you get an idea of the size of some of these rovers, including the Chinese Zhurong, which is basically a beefed up version of Opportunity and Spirit here with the solar panels and everything. I'm pretty sure Zhurong is still operating. I think it's been like 3 or 4 years, and it's still running because it landed back in I think it landed where Perseverance did, right around that same time, and that same launch opportunity. Of course, Curiosity and Perseverance are kind of mirror images of one another, except Percy's a little bigger. And the JPL engineers did not put the JPL stamp in Morse code on these wheels. And hey, funny, these wheels are lasting longer on the rough terrain of Mars than Curiosity's wheels are, because some bright individual decided they were going to put little holes in the wheels that when you drive across the surface of Mars, spell out JPL in Morse code. That's cute and everything. I don't believe that engineer is working for them anymore, if you know what I'm saying, because that caused the wheels to almost fail, especially one. I think the right rear wheel is almost dead because of the abuse it's taken climbing Mount Sharp. So this is Curiosity after, well, you can see as of last week when I got this image, she's a dirty girl. She's a dirty girl. She's been on Mars now for 12 years, and the Mars dust has shown itself to be rough. It's a good thing all those inlet ports for samples have dust covers on them, and the cameras have dust covers on them for good reason. They're just such an emergency.
Is that a picture of them actually on Mars?
Yes, yeah. So what Curiosity does is it sticks its 7-foot robot arm out with the camera on it, turns the camera around, does exactly what you do with your cell phone. Basically has a 7-foot selfie stick. So it takes about 150 images and panoramas them together to form a selfie of the rover. That's why you don't see the front of the robot arm, because it's the part holding the camera.
Where's the beam for the camera?
The what?
Where's the beam? We gotta wait for the microphone, guys.
Yeah.
Sorry.
Yeah, let's try and do the mic.
Okay, sorry. So he asked, "Where's the beam for the camera?" And I'm not sure what you're talking about. What is that? Pardon?
The beam on the arm of the thing that held the camera that took those two pictures you see on the screen.
Right.
I was looking, unless it's a remote device parked on there and they simply move into position for a camera.
No, it's on the end of the arm. So you don't see the bottom end of the arm because it's the camera's kind of like this. So the arm is, yeah. I'm not sure if it's a 360, but it's
How long does it take from initializing the code to extend the arm and take a picture and actually get an image back? Like, what's the time between first starting the whole process and then getting it to have an image over here at Earth?
I have no idea. No earthly idea. That is a question for the JPL engineer, the coders who actually write the programs. Unfortunately, we don't have a guest speaker from JPL. I tried to swing one of those, but that just didn't happen in time. Right now, the Mars engagement team is doing double duty with the short staffing at JPL currently. You might recall about 6 months ago, they reduced their workforce by about 12%. It's cut, one-eighth of them gone, on a Friday morning, bye-bye. With the result that the Mars engagement team is doing double duty with the Europa Clipper. And as you know, Europa Clipper is launching in October. So Sarah Marcotte, the Mars engagement lead, is currently, I believe, in Cal Academy doing the Europa Clipper tour. So they're trying to do too many things at the same time. This is the short answer. So every rover since Spirit has a Bill Nye designed sundial that's on it. And as you can see, high sun, low sun here, pretty much, pretty obvious, the different shadows. And Curiosity, now, when Mars and Earth are at inferior conjunction, that is, when Mars is on one side of the sun and Earth's on the other, that's a bad time to do anything regarding sending code, for example, to Mars. It's a terrible time because, as you know, the sun is a very radio noisy star, which means if you're within a couple of degrees of the sun, you're trying to transmit, what you're going to get at the other end is garbage. Okay, that would cause the rover to say drive into a ditch or whatever. So while they're parked, they tell the rover, "All right, I'll see you in a couple of weeks. While we're gone, until we get back, go ahead and do some imaging. Take a panorama. Take a sample from this rock right here. In front of you. Go ahead and sample that thing. Save the results for when we come back online in mid-month, and then they send the results later." So Curiosity, this is a great thing. If you teach third graders, one of the things they're going to be talking about a lot is the new science standards at North Carolina's public education. And they focus more on developing models and those kind of things. So when you are teaching third graders about the sun and the apparent motion of the sun in the sky and the stars as well, because they also follow that same pattern, of course, because of Earth's rotation, we could talk about the movement of shadows. And what I do with my third graders when they get to a planetarium, there's a stick in the ground. I mean, a gnomon, as you know, a gnomon does not have to be complicated. It can be anything that casts a shadow and is relatively straight up and down. Okay, unless you're building a proper sundial, but with just a stick in the ground, you can actually tell time. And so what I'll do is I'll have the shadow, and I'll put a cone down, and I'll ask the students to tell me, "Okay, cool, we're going to be in the Planetarium and Science Center here about 45 minutes. Where is this shadow going to be when we come back out?" And I actually have the kids take cones, or they're now like real estate marker sticks with the little flags on them, and I'll have 3 or 4 kids actually put down where they think the shadow is going to go. You know, I will sometimes tell them this way is east, that way is west, to give them a little help with an idea for where the sun might go, where the shadow therefore might go. I also introduced this concept with Peter Pan. Peter Pan, as you know, is caught by Wendy, or Peter Pan's shadow, rather, is caught. Starts chapter 2, and chapter 2 is titled The Shadow. Now, in our district, anyway, we've been using what's called the EL curriculum, and that uses different works of literature that tie into science and language arts. So it's a nice connection, and it's a nice way to tie the two together right at the beginning of my lesson. Anyway, so
context.
Yeah, wait, Mike.
Aside, just to clarify that Peter Pan is on the 3rd grade reading curriculum, if
Yes.
I'm not mistaken.
Oh, yeah.
Just wanted to clarify that.
It is. It is. That's why I'm doing it. Yeah, it's exactly why I'm doing it. So. You get a pair of goodies. And you also get goodies because you asked a really good question that I, once again, did not have an answer for. Okay, here we go. All right, so the nice man who doesn't know anything is going to keep talking now. So Mars started out pretty wet. And every time you turn around, there's more evidence for just how wet Mars was and is. Mars is a watery paradise. All you got to do is go down underneath, and you hit pockets of liquid water. Insight has recently found a lot of liquid water under the surface. So we have all kinds of aquifers going on under Mars. So obviously, when you bring your astronauts to Mars, you want to park them in a lava tube to live near an aquifer where you can drop a pipe, and go ahead and drill some water. Sarah Palin would say, drill, baby, drill. Sorry. So what makes a place habitable? What are the ingredients for habitability? That's a question for you. What makes a place habitable? All right, water, lack of radiation, those are 2 good things, yeah. Yeah, good atmosphere is helpful, right? Send this back, please. Nice gentleman. Sir? Oh, good. Well, give it to somebody you like. Okay, just kidding. Anyway, ouch. All right. Okay, so there you go. A source of energy, that's critical. And most people don't consider that. But a source of power for whatever living system is going to be using that power, whether it be sulfur or whether it be oxygen, some kind of something to drive the system. Okay, so these are the instruments on Curiosity. And Curiosity is built to do everything except take samples. Okay, that's Perseverance's job. But Curiosity analyzes these samples. You'll notice here a radiation instrument that's going to come in handy here in a minute. You spoke of radiation a minute ago, and that's going to show up really nicely here in a minute in one of my slides. All right, so the lowest levels of Mount Sharp, what you've got is a lake, a dried up lake bed. And a lot of our nice blue line here actually mirrors these layers that are in the sedimentary rock. And with 4th graders, which is where I usually talk about Mars, is with my 4th grade groups, we talk about the types of rocks because it's one of the things they're learning about in 4th grade is rocks and minerals. And so we talk about what kind of rock is this probably just by looking at it. And if they've already had the unit on sedimentary rocks, they're probably going to be able to come down with sediments or sedimentary rocks here. And again, more of the same. Again, mud cracking. This is a very good indicator of fossilization of water that is dried up on the lake bed. So now you have the mud cracks from where the water dried up. It's similar to when a mud puddle dries up after a rain. And then sand dunes cover the area. These these sandstone buttes are the remains of those sand dunes. So these are not actually laid down by water. This is wind drifted sand cemented together to form rock. More of that. And you can see these calcium sulfate. What's the informal mineral name for calcium sulfate? Anybody know? Yeah, hit it. No, not limestone. Calcium carbonate is limestone. It's number 2 on Mohs hardness scale. Those of you keeping score at home. Gypsum. We have drywall here on Mars, basically, which is kind of cool. And so, we can talk about habitability again. Again, the presence of liquid water, he speaks habitability and the possibilities therein. All right, so this is where Curiosity was at its 10th year anniversary. I don't have a good graphic for Curiosity at 12, but it's right about here at the end of this blue line. How about that? You can notice the difference in color here, okay? The difference in color signifies a difference in change in rock units. And I'm not familiar with what's up here. I'm pretty sure that's carbonate, but I wouldn't swear to it. Wouldn't be willing to bet on that. Let's put it that way. Lots of drill holes. Curiosity drilled one a couple of weeks ago into a rock that was made out of sulfur, oddly enough. And so that was drill hole number 42. You're welcome, Douglas Adams. Yeah. How about that? Life, the universe, and everything.
Question for you.
Yeah, go ahead.
Is there a limit on the number of sample holes that it can drill?
Well, this one doesn't have a limit. Perseverance has only got 42 tubes. I think 40 tubes, actually. And 2 or 3 of those are blanks. They take basically samples of Martian air. So they can subtract that out when they're doing the real samples, the actual rock or regolith samples in the labs. But there is no limit. There is no practical limit except the practical application of the drill itself. Okay, yes.
Yeah, I see it up there now, but I was going to ask, salt water, fresh water, sulfur water. I mean, water can be different, I guess.
Right. Well, water can be very different, and it's fresher than the water where Opportunity was. Opportunity was in a pretty acidic, salty environment, magnesium salts mostly. But, Opportunity, when it was cruising across Meridiani Planum back a few years ago, was running on very salty, magnesium-laden deposits. So very different environment on that part of Mars than here. A lot of organics, and we'll be talking about that more. Okay, so this is talking about the radiation you mentioned earlier, sir. Curiosity, actually, one of the things it did during its time out, when it was taking its picture of the shadow, it was behind this rock. And so the rock shielded it from the sun, and surprise, surprise, the radiation instrument noticed a big dip in the amount of radiation it was exposed to when it was in the shadow of the rock. So that is obviously one of the things that they're worried about is when we send astronauts to Mars, how are you going to protect them from the unfiltered solar radiation which is coming in? And even though it's only like 40% as intense as it is on Earth, it is still, it'll do you. Let's put it that way. So the clay-bearing unit, this is basically lake bed here. And this represents a unit very like the units that Opportunity was running through. I mentioned Opportunity and its magnesium environment earlier. And you can see again, more of the channel that Curiosity is going to ride as it tries to scale this Mount Mitchell-sized mountain in the middle of this crater, Mount Sharp. So opal on Mars, it's very important because if you have a resource that can be exploited, you might have somebody just wacky enough to exploit it and make money on it. Can you imagine what 1 carat of high quality Martian opal would fetch at Tiffany's? Nice, right? It would be kind of pricey. And at some point, it would become worth mining and exploiting and bringing back to Earth. I mean, at this point, I know it sounds very colonialist, but you know what? We need to get our butts to Mars. Okay. Somehow, some way. I hope not on a certain individual's rockets, because can I just say people need to sell whatever assets they have in Twitter and move on with their lives? Am I allowed to say that? Good, I just said it. Whatever. So, of course, recently you've heard probably about this. On YouTube, if you go to Aswan, if you go to JPL's YouTube stream, last night they recorded. I was like, oh, great. Great timing. If you watch that recording of Aswan Vasabada last night, you got about 80% of my presentation. Okay. And then some, because, of course, he's the project scientist for this mission, so he knows more than I do. He can answer some of those questions I'm not answering very well. But this is pure sulfur. Never before seen on Mars. Very, very intriguing. They're still trying to parse this one out. How does pure sulfur end up here in this particular place? And there's many, many rocks of it. It's like a little, like a vein almost that runs up the side of the mountain for about 20 feet. So you got all this pure sulfur. Yes, sir.
You know how big the sample is that's in that photograph?
This sample is about the size of your hand, what we're looking at here. And it's magnified with the microscopic imager that brought a little more detail to our sulfur here. I remember the caption for one of the news stories: "Brimstone found on Mars." You know. Oh yeah. Okay. So Mars is habitable for a while, and I don't know about you, but I'm getting real tired of people pussyfooting around the idea of life on Mars. Okay, we have what the district attorney would call a preponderance of evidence in its favor. Okay, we'll start with ALH 84001 there. You recall Bill Clinton's news conference, if you were around in the mid-90s. He did a news conference about this discovery here. Not saying, hey, I think we found it. You know, I think we found life on Mars. There are other non-biological explanations for this, and it doesn't help any. This is the only meteor they found this in so far. So there is only one but. You got organics from Curiosity. Curiosity nailed down and defined the types of organics that were present in this part of Mars. But Curiosity was not the only one. We'll talk about that in a minute. So you can see in the spectrograph here, all these different chemical elements that are present: hydrogen sulfide, sulfur dioxide, carbon dioxide, of course, oxygen, water in the form of tied up in the minerals, and then hydrogen, elemental hydrogen, also tied up among the rocks there. So I'll give you a minute to read this. I want you to key in on the word perchlorate when you see it. And think about another mission that landed on Mars in 1976. There are actually two of them. So do anybody know the names of those missions? Yes, sir. Viking, yes. The Vikings 1 and 2. And yes, I'm going to bring up the ghost of Gil Levin. You know, some of you know who he is. We'll talk about him more in a minute. Have we all read this? Everybody on Zoom, are we good? Ignore the blue line. If you haven't figured it out yet, it's not just Curiosity either. All right, Phoenix detects organic compounds out the wazoo near the North Pole of Mars. We also have liquid water droplets that are forming on the arms of this thing. Now, those water droplets are not drinkable. This is very, very briny water, turns out. When Phoenix is able to analyze this with the spectrum, a lot of salt. Again, magnesium salts and perchlorates in this water, but that's what allowed it to become liquid at that very, very low pressure Remember, water is not normally a liquid on the surface of Mars because of the low atmospheric pressure. Any water that shows up on Mars immediately evaporates. Okay, so when you get a trickle coming down the side of a crater that you've seen from the Mars Odyssey or global surveyor images, those trickles don't stay trickles very long. They dry up in a hurry. And these dry up by the end of the day. Opportunity found a lot of organic samples in its 28-mile run. So let's see, we've got Curiosity. We've got Opportunity, and I think Spirit, when we got to the white silica area, found some organics in amongst that. Opportunity, did I say Opportunity right? Yeah, okay, sorry. And Phoenix, that's the one I didn't say. Okay. So we have lots of tools for exploration. I don't know why this slide is here, excuse me. Ignore that slide. All right, so recent rock discovery from Perseverance. Speaking of organics, let's find out why this particular one is so important. You might have heard about this one already. Does anybody know the name of this particular sample? I mean, I'm asking some upper level stuff here, but it's going to become very famous when that sample comes back to Earth and they find the microbes in it. Okay, I'm sorry, I'm done because I'm too old to pussyfoot around with this. No. Okay, so hopefully that will play the video. He says, "Come on."
What does this rock have to do with our search for ancient life on Mars? Everything. I'm Morgan Cable, a scientist on NASA's Perseverance rover team. Let's take a closer look. 3 things about this rock jump out at us. These whitish veins of calcium sulfate are clear evidence that water once ran through the rock. In this reddish middle area, the rover's Sherlock instrument detected organic compounds. And these tiny features that look like leopard spots, Pixel found they indicate chemical reactions, which could have been an energy source for microbial life. We've never seen these 3 things together on Mars before. We have lots of questions about how this rock formed and whether it hosted microbial life billions of years ago. But to fully understand what's going on here, we need to get these rocks back to labs here on Earth. In the meantime, as the science community investigates this data, we've added a sample of this really compelling rock to Perseverance's collection. It's awaiting retrieval by a future mission, and we can't wait to study it up close.
Woo, excellent. So, was or is there life on Mars? The litany, okay, the roll call of rovers and landers that have found organic chemicals on Mars seem to suggest that the Viking instruments weren't working right, or that there was another thing going on the surface of Mars where the 2 Vikings were. Remember that perchlorate I mentioned earlier? Perchlorate is a very, very active chemical compound that destroys organic compounds, organic molecules. It would make a great pesticide if you were very indiscriminate about the pests you were killing, because it would kill everything. Okay? So the questions or the evidence mounts. And at some point, you got to throw up your hands and say, what other explanation is there? You remember that guy named Occam back in the 12th century? He came up with this thing called a razor of some sort. The simplest explanation is probably the right explanation. Okay. If the wife is murdered, who do you talk to first? The husband, right? Okay. That's a 60-40 shot right there if you're a prosecutor or a detective, right? Okay. So at some point, we got to say, all right, look, the evidence outweighs the doubters. I mean, the evidence is conclusive, and especially when you run this little bit. Back in 1976, Gil Levin's experiment called the labeled release experiment released a sample of Mars atmosphere into a controlled environment with Mars soil. Okay, they raised they raised the temperature of it, they added some water to it, and then let it go. And this, see this wavy, bouncy up and down thing going on here? That corresponds to Mars's day and night cycle. Interesting. Okay. And that result from both rovers, but especially Viking 2, because Viking 2 with the sampling arm pushed a rock aside and sampled underneath the rock where the UV radiation didn't go, right? Rock is blocking the UV. So those, if there were organisms there, they had the ability to, I don't know what that is with the blinking. Is that a, okay, are we losing a bulb? So that's what usually happens everywhere the bulb goes out, all kinds of wonky things go on with the image, and then boop. So Gil 11 and the article, where's my article? Dang it. The article that Gil wrote, I wish I'd brought it, but apparently I did not. Anyway, he wrote an opinion paper for Scientific American in 2018, shortly before he passed away. So what he says, you can read it. Why has this experiment not flown again? What the heck? We've had 10 Mars missions since Viking, both US and ESA missions, and Chinese missions for that matter. Why not? Why in the hell not? What? At some point, you have to start wondering, why not? It's a perfectly legit experiment, and this is the same experiment or same flavor of experiment that Louis Pasteur did 200 years ago, or 150 years ago, when he was trying to rule out the presence of when he was trying to rule out spontaneous generation. Okay, he ran this experiment. And so Gil, of course, did a much more compact version of Pasteur's experiment, but why haven't they flown it again? And obviously, while he was alive, Dr. Levin was pushing very hard for this experiment to fly on another mission. Never did. Why? I mean, why would you not seek independent verification of your results? I don't get it. This is one of the most frustrating things about Mars exploration to me. Why they didn't do this experiment again. And I would hope that, that people, as they see this, would write a letter to their congressman saying, hey, maybe this instrument ought to fly. And if the instrument was capable of flying 50 years ago, it's more than capable of flying now. And I'm sure it can be shrunk down and minimized where it could fit in the size of this. It fit in a box a little bit bigger than that on Viking, but it would be miniaturized now with all the components that you could miniaturize down. All right, this is an activity I like to do with students. So we're kind of getting off the life thing. All right. So does anybody have any questions or comments about the whole life on Mars thing? Yes, sir. Sorry. Whoops. Whoop.
When are we expecting the Perseverance samples to arrive back on Earth?
That is a really good question. The answer used to be 2033. But Congress took one look at the $12 billion price tag, and they said, no, thank you, especially this Congress. Maybe a different Congress in 6 months or so may have a different opinion. But for now, that mission concept is put on hold, and NASA's been told to go back to the drawing board and design a cheaper mission that can go get those samples. I have a feeling it may end up being, who to the rescue. With a Falcon Heavy or a Starliner or something going to get them. He who shall not be named. Because I don't think so. I'm not going to call his name out and give him any more publicity than he doesn't need. Here you go. And would you prefer Mars or Jupiter? Postcards. There you go. We're here for Mars. Yeah, fair. All right. Yeah, I've run out of the Europa cool 3D thingies. Anyway, This is very simple. It's from NASA's engagement team. They did this, I believe, for, I can't remember which mission they did this for. It might have been Sojourner and Pathfinder. Okay. This is especially important. When is the opposition of Mars coming up? When? January. Okay. I think that's right, isn't it? Here you go. While you're looking that up, I'm going to just say this is a great activity to do in conjunction with your Mars opposition events. Because what you do, you set up 4 blue objects. They don't have to be cones. I use cones, but you don't have to. 4 blue objects around a central object that would be the sun, of course. And then 8 orange or red cones or other objects in a larger circle, about 1.5 times out from the sun and Earth, just like Mars, right? And as what happens is you have 2 kids that are you start here, and then you say something, you say a code word, like I use Go Gators, University of Florida, you're welcome. What I'll do is have them go to the next cone of their color. When they're here, I have a little foam rocket that I have Earth put on Mars's left knee. Where basically go and toss it and it hits Mars's left knee, right? And I use the left knee because it's pretty safe. I suppose you could use somebody's ankle or somebody like that, something like that. But I don't want any body shots, and I certainly don't want any head shots, right? Foam or otherwise, I could still freak somebody out. So we don't do that. But anyway, and then we go through 4 after 2 of these. Okay, I tell the kids that are watching, the other kids playing. Yes, sir.
In the lower part of that image, that little bitty rectangular box, I see a Mars corona.
Mm-hmm.
And when you was mentioning life on Mars, I heard some people say that Mars may have been inhabited and may have gotten destroyed by a really big nuclear war. Although whether that's true or not, if it's not, then it may be all made up.
Well, I'm pretty sure let's just say there isn't good evidence for any of that. The nuclear war thing, because we don't have any residual radiation for one thing. And you don't have any of the structures that denote a nuclear explosion. So right away, that goes in the file under conspiracy theory area. What happened? Sorry, what? Okay. Oh, sorry.
Said it all. January 16th is the next opposition.
Thank you very much. January 16th. So right around astronomy days. That's convenient. Right? Right around astronomy days. Well, you guys do astronomy days every year, and I got to give you props for that because that's one of my favorite activities to do every year. Turning this whole building over, the set of buildings over to astronomy. It's a beautiful thing. So you guys do a great job. So thank you for that. Because I love, for the last 18 years or so, I've come up that weekend in January or February to be a part of that from Lumberton. And I really appreciate you guys offering that opportunity. So thank you. Speaking of that. So some educator resources or outreach resources for you as you're leading events for the different missions. If you just want to take a picture of this page, it's probably not a bad idea because you got all those links there. If I really had my stuff together, I would have had a QR code for that, but I did not. So I'm sorry. Is that the 10-minute bell? The hour bell. Oh, well, I didn't start it. Okay, come on. Let me know when you're all done with it. Yes, sir. Go ahead.
So is the plan for Curiosity to reach the summit of Mount Sharp? And if so, how long do they expect it? Much longer do they expect it to take?
Well, Curiosity has a problem, and that is the rate of decay of plutonium. Realistically, Curiosity is only going to be able to run at optimal strength for about another 18 years. And after that, the decay of the plutonium, the power source for the nuclear reactor, starts to not be sufficient to run all the instruments. And so they'll have to do some rationing Short answer, they're not making it that far. They're not going to get there. Okay, that's not going to happen. What they're hoping to do is get as much science out of that rover as they can get. Just like every other rover, drive it until it stops. Yeah, go ahead.
I was curious if they have found any fossils on the planet, like plant that would show there might be some plants way back when.
I didn't even go into the algal mats that Curiosity saw near the base of Mount Sharp, what looked like algae mats, okay? And Perseverance's run its stromatolites, or what looked like stromatolites. Again, more of this, well, I guess you'd have to call circumstantial evidence, but still, the evidence keeps mounting. All we're missing is an actual, the body. You know, you got to have the body. The nice thing about Perseverance, she's drilling 40 of those or 37 of those. And that's where you're going to find the bodies. Okay? It's a matter of time. So whenever they got those happy samples back to Earth, give it a year. And one of the cool things I tell my students, well, I'm near UNC Pembroke, which is a smaller one of the UNC institutions. By the way, it's one of those $500 a term places. So, you know, hey, if you've got a kid that wants to go to college and you don't want to spend a lot of money, Pembroke might be a good place for them to go. Anyway, one of my colleagues at Pembroke, Stephen Sinclair, is a scientist currently working on Mars meteorites. And it would make sense that he would probably get a small piece of one of these samples. Wouldn't it be cool if one fine day in the front of the main building at UNC Pembroke, there's a microphone set up with the NASA logo and a podium, all right? Dr. Sinclair is there with the NASA administrator, and they are announcing the discovery of life in the UNCP's scanning electron microscope, okay? Which, of course, you can't bring to Mars, but you can run a UNCP. He's got one of those, and he knows what to look for. That would be very awesome to have a little homegrown announcement of life on Mars go out to the world from my backyard. It'd be very cool. More resources for you. We got resources for Perseverance, of course. Not as much for Ingenuity because, as you know, she's grounded until such time as someone gets up there to repair her. She's going to stay there where she is now. So all of these are Perseverance resources. And you can still find out where Ingenuity was and Ingenuity's path across Jezero Crater and the Delta and everywhere else it flew. Again, another wildly successful, over-engineered mission. Thank you, JPL, for doing your job so well. I love working with these people. Then we got JPL's Mars Public Engagement Office, which, as I said, as I've already told you, is doing double duty with Europa Clipper right now. So they're a little bit harder. You might want to allow a little more than 6 weeks. I know 6 weeks wasn't enough for me, unfortunately. A lot of good informal education activities and lesson plans that are aligned to the next generation science standards. Okay, they're not aligned to North Carolina science standards, but North Carolina's science standards are basically the poor man's imitation of the next generation science standards. They just wanted to keep it. We want our own science standards, so they kept those. Talk to the nice people across the street about that nonsense. But anyway, this is a lady to talk to about Mars resources. For example, a few years ago when we had the models of the different spacecraft here, she's the lady who got them here, talking with Carrie Bean from the museum, et cetera, to get those things here. I think this might be the end of my slides. Oh, I'm wrong. Okay. If you ever get a chance, have a look at the decadal survey that the National Academy of Science, Engineering, and Medicine puts out, the Planetary Decadal Survey. The key for Mars exploration, get those damn samples back to Earth by any means necessary. That is number one priority. And so I'll go back to the political argument. Maybe somebody else goes to get those samples. There's no reason China can't do it. Hey, they got the time and the money. They've got the know-how now. They're running a successful rover. Go ahead.
My understanding is the original plan is they were going to drop samples along the route, and that they may have changed it. They're just going to drop them all in one spot. Do you know about that?
They've dropped like caches in different places.
Okay.
So they're like 4 or 5 samples go in each place, and they're all in a pretty straight line shot route for a future rover to go pick up, or a future helicopter rover to go pick up. And that's the thinking now, is that the pickup machine may be an 8-bladed helicopter with a grabby thingy on it and a container to stick the samples in.
And what was the rationale for that versus just keeping them on board the rover?
I'm not sure. Once again, you've stumped the chump.
You already got me.
As they said on Car Talk.
You've already got me. I'm good.
You already got you? Okay. All right. All right. Does anybody else have any questions about any of this? Yes, sir.
Well, I know that Mars, for instance, that when the sun's between Earth and Mars, there's a communications blackout. Is there any plan by any space agency to deploy some satellites around the solar system so they could get around that issue?
That's a good idea. No, not that I know about, but that doesn't mean they don't exist. I'm sure there are all kinds of plans. These people have a lot of people working on projects just like that. But in terms of that we know about, no.
Yeah, Mars is supposed to have had a magnetic field.
Yes.
Which doesn't exist anymore, and ALH 84001, etc., have shown a little bit about existence of magnetic field, if I recall correctly. So can you throw a little bit more light on experiments that were aimed at learning more about this?
Yes, there's actually many, many micromagnetic fields on Mars. So there are small areas, like usually associated with a metallic impactor, that creates a local magnetic field. It's pretty weak, but it's a magnetic field. And this is something you can work with. If you build your habitat there, you have a little bit of shielding from that field from the incoming radiation. Not much, but a little bit. And maybe lining your outer tube of your habitat with water, something else to shield, or building your habitat inside a lava tube, and just sealing off both ends of the thing. So you have, and then you pump air in it. And now you have a submarine, basically, on Mars. But there are micromagnetic fields. And if you look for magnetic fields on Mars, you'll see a bunch of little tiny red and blue lines that correspond to the sub. It's not a global magnetic field anymore. If it had one originally, well, it did have one originally, but the core has dried out a lot for the most part, and so the magnetic field doesn't exist anymore. Yes, sir.
So do satellites like Starlink, do they interfere for like signals being sent to Mars for like the rovers or anything else? Do they interfere at all, or could they potentially in the future interfere?
I don't think so, because the satellites are more of a nuisance for anybody who's seriously into astrophotography. Even those satellites are removable. That's a fixable thing. You just remove them from your image before you release it. But and you make note of the fact, 22 Starlink satellites were removed from this image. So you're full disclosing, what happened to it. So imaging wise, it's a much bigger problem. I don't think there's much radio interference we'll have to worry about. No. Yes, sir.
We have a question on Zoom. What is the nature of the surface radiation, protons, and other particles?
Well, you got this thing getting bathed by ultraviolet rays and whatever else is coming down from the sun. I don't know if the solar wind actually makes it to the surface. I don't know enough about that. But to answer that question in greater depth, you should go, and I'm talking to the person on Zoom, you should go to the MAVEN website because MAVEN is analyzing that, as are the rovers on the ground. They're also analyzing the radiation coming in. So they can tell you exactly what type of radiation it is and how much of each type is coming down. So that information is available on the internet. I just don't have it.
Any other questions? One more.
Yes, sir.
Okay. One moment.
One of my thoughts has been regarding the sample recovery with the time they're expecting before they get a mission. Why not just forget about that and eventually just send a person there to go collect it and get it in person and do the experiments on Mars? Why not just do that?
Do the experiments on Mars is the hard part because you need the lab equipment to do the experiments on Mars. A scanning electron microscope right now, does anybody work with those at all here? I probably have somebody here that works with some or knows somebody that does. These things are pretty big. And so getting an instrument like that to Mars is a challenge. Okay, now maybe it becomes a priority and it's worth the extra rocket power to get it there, where you send it there in pieces and you assemble it on Mars. I don't know. But honestly, I see where you're going with this. The timeline for human exploration is meshing pretty closely now with the time for when these samples are supposed to come back to Earth. Because if Elon has his way, he plans to live out the rest of his life on Mars. Anytime, bud. Anytime. Hit the road, pal. Take the first train out, buddy. Please. And take Twitter with you when you go. Sorry. I did not say that out loud. Did I? Oh, oops, too late. Anyway, take Twitter with you when you go, pal. Yeah, go ahead.
I think last question.
Okay, last question. Here we go.
So I'm sure there's plenty of geological modeling. So two things. One is sulfur outcroppings. You'd think that'd be associated with volcanic activity.
Mm-hmm. Yeah. Yeah, if you go to Italy, that's where you find, Solfatara,
are they already working on trying to figure out whether it was underwater volcanic activity versus surface activity?
Those are all really good questions I don't have an answer for. So once again, the chump has been stumped. All right, I knew that was going to happen a lot tonight. Sure. Yeah, please. Yes, you do. All right. All right, good. Good. All right. Any other questions? No,
well,
we're done.
I think we need to wrap it there. There's one comment on Zoom I wanted to read because it really sums up the talk. Thank you very much. It says, thank you for this evening. It's been great. I am not any kind of scientist, and I think I got pretty much all of this. Good job all around, from Betty Ann. And I second that. Thank you, Ken.